All right, cool. Yeah, so my name's Nate. I'm going to be speaking about quantifying the Oracle problem, introducing a metric that we use at Token Dynamics that I think is going to be helpful for all of you in thinking through problems related to Oracle security and fundamentally the security of the data that is coming from Oracles. And we're going to be thinking about talking through the value that underlies that data. So my name's Nate. I'm the of Token Dynamics. We're a protocol design firm, and we have a focus on economic security and on value to a token. Let's see, we got some. You guys good on the mics? All right, great. So with that, I want to introduce the Oracle problem. So I'm a little wary of doing this at a conference on Oracles. First of all, the meme you see on the right is not the fundamental Oracle problem that we're talking about, but people typically conceptualize as the how to get Web 2 data or data from outside of Web 3 on chain. And I want to reframe that a little bit and talk about the ways that we try to get data to interoperate between systems with fundamentally different security, namely economic security assumptions. And so talking about economic security, this is where technical security is a lack of bugs in the code. Economic security you can think of as a lack of bugs in the incentives. And so the functional definition of an economic vulnerability is something like no matter how you code and develop the application, it's still going to blow up because there are fundamental misalignments in the design phase rather than the implementation. And typically, all economic vulnerabilities come from a way to profit, change, appending, or omitting data that should be there. And to do this, we're going to put all of the value and that sort of the variables behind this data, the economic value that is backing it, into like terms. All right, we're going to switch over to a mic here, a little better. So we're going to talk about how to put this into like terms so you can do useful calculations with this value and calculate how secure a given piece of data is or how much trust you should put into it. So this term we call crypto economic authority. This is the quantifiable amount of trust behind any given piece of data on a blockchain. And everything can be reduced to the cost that it takes to change that piece of data. So like I said, append, transform, withhold, these are the few ways that you can change data on a blockchain, and you can quantify exactly how much this is for anything that lives on chain. You can approximate it for things that are off chain, and you can sort of use proxies to calculate what this might be to get a range, a band of how secure a piece of data might be or how much trust you can put into it. So the first example I want to use is just going back to the basics with Bitcoin. The security and the trustworthiness of a given transaction on Bitcoin is proportional to how much hash power has gone into it nominally, but there's also other factors. There are the cost of the ASICs and how much value those ASICs would lose if people were to double spend. If miners on BTC were to double spend, the value of their ASICs goes down. So note this is not the same for chains that are forks like BSV. BSV has been reorged a bunch of times. As far as I know, no one sold their Bitcoin because of it. And so this is part of the calculation of crypto economic authority on the Bitcoin chain. The longer the blockchain gets, the more secure the past transactions. And you can also think of the future cash flows that the miners would expect. All of these three things, the electricity for hashing, the ASIC value, and the future cash flows of the businesses are considerations in the crypto economic authority of a given transaction. And this works when BTC is the only asset, but it starts to break down when you have exogenous assets that are bridgeable out of the chain. So, for example, Tether used to be on Bitcoin. You can imagine a profitable double spend where someone double spends $1 billion of Tether. That's checked by the exchanges actually doing these types of calculations to figure out how many blocks deep they're willing to confirm and say a transaction is final. But ultimately, that is a calculation that everybody who interoperates with a bridge is making or should be making, is making or not, to their detriment. And so the second example I want to go with here is just a basic like implementation of an oracle, like a naive proof of stake system. So you can imagine a system where one oracle is randomly selected and they all stake about the same. This was for the World Series baseball, Los Angeles Dodgers versus New York Yankees earlier this year. And if you get a randomly selected oracle to report on this, you can only be as sure of their reporting as they have stake in the system. So the value of their stake can't be any less than the value of the bets that they're reporting on. Otherwise, they're likely to, there's a moral hazard there. There's an economic security vulnerability. So super basic example, but just to illustrate the point before going into an actual vulnerability, this is an Oracle exploit that you all might remember. Bonked Out was a stablecoin protocol, and they had a reporting through Telor, and they had an improper implementation of Telor where they didn't use Telor's time delay and challenge period to augment the CA, and I'll talk about that in a sec, but basically the attacker, who was probably an insider, staked $180 of TRIB to change the price of one of the collateral assets. They made it $13 billion, and then they took all of the treasury. The protocol lost something like 13 billion. There was some contagion there with the asset, or 13 million. There was some contagion there with the assets, and the attacker netted $1.7 million just for a $180 investment. So this is one of my favorite economic vulnerabilities that's happened in the past. Also the name, just the memes, it all tied together really well. And so if you reduce this to numbers, fundamentally, the crypto economic authority of what was being reported wasn't high enough. And that's, again, because they didn't implement Telor properly. There were additional dimensions. There are additional dimensions in the Telor protocol that they could have implemented, giving it optimistic security. And when you get optimistic security, you're basically, the crypto economic authority is as much as people would be willing to put up, as much as they have on tap, basically, to challenge whatever the original incorrect value is. And so I want to talk a little bit about the trade-offs here. So you can think about the fundamental trade-off between doing everything on-chain versus everything on-chain in extremes. And the trade-off here is basically between enumerating everything and making it public for everyone to calculate. It makes it a little easier to attack when everything is public and you can do these economic calculations as a red teamer. So you have to get creative and find solutions, algorithmic solutions or game theoretic solutions like Telor has with the challenge period and optimistic security assumptions in order to solve this problem. You can compare that with Chronicle, who has a really creative solution as well. They have a handful of companies that are signing off on the data they're providing. And so the crypto economic authority is coming from these companies' goodwill and their future revenues. So there's a vested interest in these companies, or by these companies, in reporting the accurate, correct data. And again, that's using crypto economic authority, but it's a little bit hidden. And so this looks more like a lower bound, saying if you trust these companies to this certain amount and you see their revenues, there's at least some number, at least $1 billion or whatever their, some fraction of their value is backing each of these pieces of data until there isn't, right? Until one has a fault, and then new multi-sig set, and you can keep upgrading the signer set to augment the crypto economic authority. So these are just two different approaches. One is fundamentally more off-chain, one is fundamentally more on-chain. And the question for oracles that underlies or that stems from crypto economic authority is how much value can we secure? And even further than that, when you're building an oracle, you're thinking, how do we monetize this? How can we effectively charge for this? And that's also going to be proportional to how much value you actually secure. And so I want to talk about this concept of money Legos. There are two good ways to build with crypto economic authority in mind. You can build vertically integrated, where each layer is not making any more demands on the layer below it. The sort of the delegated crypto economic authority of a piece of data at layer 0 or layer 1 is at least as much in both of these cases as the layer above it. And so these two first ones fit that economic authority profile. So the last one, though, this is like where you would have a layer that has too much value, too much TVL, depending on the layer below it. And so if you were to put like a physical diagram to the kinds of vulnerabilities that we've seen exploited in the past, whether those are oracle manipulations by replacing the oracle or price manipulations by changing the underlying value through a flash loan, swapping through an AMM, or even TWAPs, that's going to look more like the sombrero hat pyramid on the right. So just to give you a quick physical diagram before going into the next example I want to talk about, something I've been really interested in is ZKTLS. And so this stack over here is like loosely mapping to the security and the crypto economic authority of these pieces of data at each layer. And you can see it stacks really high before it even gets to Web3. So ZKTLS notary networks have their work cut out for them. And the reason I mention them is they're kind of like a pure form of crypto economic authority and economic security calculations. For anyone that doesn't know, ZKTLS is ZK proofs bringing Web2 data on chain. So the problems stem a lot from the base layer, where there are many ways to manipulate the underlying data that are not necessarily that expensive. You could be a Facebook employee and change Facebook data. You could hack into their servers. You can get physical access to someone's Facebook. There's a lot of different ways, and many of them are rather cheap. And so the value that the data, depending on ZKTLS, gets is limited, or the value that you can build on this type of data is limited by the security of the data itself. And to quantify that, you want to be thinking in terms of crypto economic authority, loosely maps to cost of attack, also abbreviates that way. But these are a couple of the considerations for notary networks that I wanted to highlight as an example of a protocol that is going to need to think deeply about crypto economic authority. So in summary, this mental model of like this metric of CA can tell you how secure a transaction is. If you're a user, you can be thinking as an oracle about how much you secure and how to monetize what you are providing, and how to select an oracle in the first place, because different oracles have different security assumptions, and those are all basically reducible down to CA. There are other factors in oracles, but what you want to make sure is that you align your security assumptions as closely as possible, or those are transformed properly into this reducible number, or this irreducible number of crypto economic authority. And so as a final thought, if you can't calculate the CA, this should be sort of an orange flag for you. It's like, where is the authority coming from? Where is the trust coming from if you can't actually calculate it? And so there are many pitfalls that come with calculating. The main one that I want to flag for everyone is assuming that the number of staked tokens you have times the last traded price is like the dollar amount of the value of those tokens. That mental mistake has underlied most of the economic vulnerabilities that we've seen in the last 5 years. So Terra Luna being like the main one. Obviously you can see that Luna was not worth what it was nominally worth as an aggregate. And so the other follow-up question to this is, how do you design protocols to be built on? And you want to be thinking, again, in terms of crypto economic authority, how many outside dependencies and how much TVL can depend on your protocol is a function of the crypto economic authority that you create in it. And so this is my contact info. That's what I wanted to share with you all today. If you guys have any questions, I'm happy to field those if we have time. But yeah, feel free to scan the QR, and I'll be available the rest of the next couple hours. All right, thank you.